Now, I created some tutorials to help you better explore your own concept, your conceptual understanding of electric potential. Okay, so let's go ahead and start off with this first tutorial in voltage. Okay, so this first page is where I'm going to give you some electric field lines and voltage lines of two different charges, Q1 and Q2. And then I'm going to ask you questions, whether or not, based on what you're seeing there, is Q1 the same thing as Q2, or is one larger than the other? Which one has more charge on it? So in this case, I have two positive charges. Which one do you think has more charge on it? And you probably need to explain why. Okay, so and how charge is related to electric fields. So the electric field, what's the electric field at A compared to the electric field at capital A? And what is the voltage at A compared to the voltage at capital A? So which one's higher up? So you're going to have to answer all these questions. So here, just on this one, how is the electric field at lowercase c compared to the electric field at lowercase b? Okay. And what is the electric field at lowercase d compared to the electric field at lowercase c? Okay, and then back to this, where compare the voltage at lowercase e to the voltage at lowercase capital E, and compare the voltage at lowercase d to the voltage at lowercase c. So try to answer all these questions and then do the voltage difference in here. So pause the video now and try this out. Okay, we're back. So in determining the overall charge, what I do is I count the electric field vectors. Here I got 1, 2, 3, 4, 5, 6, 7, 8. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it looks like this is positive 2Q, and this would be positive 1Q here. So this is being a positive 2Q, and this is a positive 1Q. This is going to be less than, which means the electric field vectors here, there's less electric field vectors if I just drew a line across this right there, going through there, versus if I took the same line and drew it across there. So here I'll have almost 4, I have 3 lines going through it, and here I only have 2. So the electric field at capital A is greater than the electric field at small a. And that also means, since this is positive 2Q, it's twice the height up than the voltage at A, right? Capital A is twice the height than this one is, since it has twice the Q. Since this distance is R to here, and this distance is 3R away, so this is 3R, so 1, 2, and 3. This is 1, 2, and 3. So anyways, here's what you get. Now, just looking at one charge, if we look at the electric field going through this line versus something like that, these two guys have the same electric field since they're the same distance apart, so those are equal. And when we look at the electric field at D and compare that to the electric field at C, again, C is closer to the charge, so it's actually going to have a stronger electric field than D. So these two guys are equal, and this is C is greater than D, or D is less than C. Now comparing the voltage at E here and the voltage at E here, voltage at capital E, again, is larger than the voltage at lowercase e for the same reason that capital A is greater than smaller a. And comparing lowercase stuff, the voltage at D is less than the voltage at C, because C is higher up than D. So So these two are related to each other. And finally, if we look at the voltage difference between D and E, well, they're on the same line. So the voltage difference between them, you've got like, if this is positive 20 volts minus positive 20 volts, that's just 0. And B and C, that's on the same voltage line, so that would be like positive 50 volts and positive 50 volts. That would also be 0. So the voltage differences are 0 there, are equal to each other. They're both 0 is equal to 0. So this is your very first page of your tutorial, okay? So you'll have to do something much like this. Sorry, the screen jumped just there. Your second page of your tutorial, you'll be given two situations a little bit different from this, but something within your range, and you're just supposed to figure out the voltages at these points, along these points, and determine which voltages are greater and which voltages are smaller, right? And arrange them from higher voltage to the lower voltage. So in this first case, you have a negative 2Q on the left and a positive 1Q on the right. And so you're supposed to arrange these letters from largest voltage to smallest voltage. Or in other words, highest height to lowest height. Try it and pause the video now. Okay, well, in this case, we have to draw little rings based off of these distances, okay? And so if you notice, this distance and this distance are the same distance, but D looks a little bit further away, right? Just slightly along that ring. So you'll have little rings around these guys, okay? But the problem with C is it's really close to that negative Q. So the voltage is going to be dropping off really quickly, okay? And so we did this, something like this, earlier right over here, okay? So you're supposed to kind of maybe refer to this picture when you're doing it, okay? But if you look at it right here, we're looking at distances. Now just the distance is actually, it is important, okay? We're looking down on this, right? But E is going to is further to the right, which is going to be higher up, right? So the voltage at E is higher up than all the other voltages. Okay, now the voltage at E, since you're getting now notice D is closer to this negative 2Q charge. The closer you get to that negative 2Q charge, the weaker the voltage, right? Notice how far away E is from that. So voltage at E is going to be greater than the voltage at D. And then you get to the voltage at C, okay? So what this is looking like towards me, for me, is right there. And then the voltage at C, now we realize the voltage at the voltage here at C is probably going to be closer to 0, right? So the voltage at C so the voltage at D is going to be greater than 0, but the voltage at Z is going to be probably closest to 0. In fact, right here is where it's going to be around 0. So we know the voltage at C is closest to 0. And now notice that this B is further away than C, right, from the positive Q, right? So now we know the voltage of B is going to be less than the voltage of C. And notice the voltage of A is the furthest away from this positive Q. So that's what I do to think about voltage, is think about the distances to the charges, and the further you get away from a positive Q, that's going to be a lower positive voltage. And if that further distance is closer to the negative 2Q, now you're just deeper underwater. So we've actually arranged this by height. E is going to be higher up than D. D is going to be higher up than C. In fact, C is going to be close to 0. And B is going to be underwater. And A is going to be even deeper underwater. Okay? So now that you've learned that, let's see you try this one here. Okay? So try pausing the video now and reevaluate what you've done here. Okay. So again, this A guy is furthest away from this negative 2q charge, right? So you kind of have to look at this as the opposite of reasoning. So the voltage at A here is going to be greater than any of the other voltages. But now, if you look at C and B, those two guys are equidistant to the negative 2q charge, and they're equidistant to the positive charges right there, that distance and that distance, right? So you could say that the voltage at B is equal to the voltage at C, and now the voltage at D, which is, my guess is probably where it's closest to 0. And then finally the voltage at E is the deepest part, it's underwater. Again, D is closer than E is to those positives. So that's the reason why D is is higher up than E. Okay? So you'll have to do this, and this is a good exercise to see if you get charges and how it works. Okay, and the quiz is going to really help you out with this. All right, with this. So basically, all of this is just the conceptual quiz. So you're just basically putting in your answers to the conceptual quiz. Finally is an interpretation of a voltage map. Okay, I love this because you have to consider all the concepts that we learned in the lecture, okay, in interpreting this voltage map. Okay, so first of all, you're supposed to determine the electric field vectors at each one of these points, A, B, C, and D. Then you're supposed to rank those electric field vectors in terms of strongest and weakest, and rank the voltages from highest to lowest. And then finally, the last question is, look at the voltage difference between A and C and the voltage difference between D and C. Which voltage difference is larger? Okay. Let's actually start with the voltage part. So if we look at the voltages, this is 100 volts, and then we don't know what this voltage line is, and then this is 0 volts. And then we don't know what this voltage line is, and then this is -1 volts. So if you're looking at that, we could assume from going from -100 volts and then blank and -200 volts that this is probably -150 volts, right? And then this is -200 volts. This is -100 volts. This is going to be -50 volts. So it looks like the voltage difference between lines is 50 volts. Then we got 0 volts. Then we have +50 volts. And then +100 volts. And this one would then be +150 volts. And then this line, which we could barely see, is going to be +200 volts, right? And we could count up from here. This would be -250 volts on all along these lines. So if you look at A and D, they are both equal to each other. So the voltage at A is equal to the voltage at D. And both of those are larger than C. Now you're underwater at C. The sea level is right here. Okay? And then you look at the voltage at B, which is the deepest underwater, which is -200 volts. Okay? So those are the voltages. Now, we know the electric field is kind of pointing up and to the right. It's got to be pointing downhill. The electric field lines need to be perpendicular to the voltage lines, okay? Now, we have to think about it. Now, the slope, which is the voltage difference, the slope in between each one of these lines is the electric field, right? So where do you think the slope is steepest? So if this was a mountain, okay, this would be nice and level, and then it looks like it's getting steeper and steeper and steeper and steeper and steeper underground. So where the voltage lines are closest together is where the slope is going to be the greatest, okay? So I guess what I'm saying is, if you look at the voltage difference between here, look how long this line is. If I grab a vector, or go from here to here, and then this, and then we have this, so this has got to be bending a little bit. So this one distance that's in between 1, 2, and 3, now we could do this distance in between these ones, and this distance in between these ones, right? And draw the distances in between these ones, right? So where is the electric field, the voltage lines most concentrated? Well, the electric field, and we're just thinking about the magnitudes of these, at B is the most concentrated, right? And then it looks like D has a larger concentration than C. And then finally, A's concentration, which, density, is really small. So we're just looking at the magnitudes of those numbers, right? The larger value, stronger, okay? Now, if we erase all that, well, actually, let me keep it. A larger, so the electric field lines have to point downhill. So if B is the largest electric field line, electric field vector, it's got to be strong and pointing downhill and perpendicular to these lines. Then we have D's electric field vector, which is going to be the next largest. And then we have the third largest, which is this one, electric field at C, which I'll draw off to the side here. It's going to be smaller than D. And then A's, I know this is a long distance, but you have to kind of think opposites. This is really level. So if you're thinking about water flowing, the water isn't going to be flowing very well right here. This would be the direction that the water is flowing and how fast it's flowing. So it's going to be flowing really fast here downhill. It'll almost be a waterfall. And it'll be flowing quickly here, not as quick here, and it'd be barely flowing right there. So I'm actually going to make this much smaller, right? So that would be all the electric field lines at that point, at those points right there. Okay? And now for the voltage difference part, for this last part. If we compare the voltage difference between A and C, and let's go C minus A. Okay, so voltage A minus C. I'll just interpret it along those lines. And we're just consider the voltage difference. Okay, so A's voltage is going to be positive 50 volts minus C, which is negative 50 volts. So this is going to be minus a negative 50 volts. Well, positive 50 minus negative 50, that's going to be plus 100 volts. And now if we do the voltage of D minus C, well, D is on the same voltage line. So that's going to be positive 50 volts minus a negative 50 volts, which is going to be a positive 100 volts. So these two things are the same voltage difference. When I say voltage difference, I don't care about distance. So notice the distance between A and C is longer. A lot of us would say the voltage difference between A and C is greater than the voltage between C and D because their distance is closer together. That is not true. With charges, you don't care about distance, you care about voltage difference. Okay? So, there we go. That's how you interpret so this is the approach you should take to your third page of your tutorial. Okay, thank you very much. Have a great day.